opportunity to speak. Going to be talking about enhancing quality via Design Assist, which is a contracting and design assist method that we use to ensure qualities in all of the facade systems that we are putting in, whether it's waterproofing, glazing, metal panels, so on and so forth, up to roofing. So we're going to talk about just L.F. Driscoll, how we sort of house subject matter experts in order to support these functions. Talk about the design assist objectives that we are constantly trying to improve, and then talk about system design. And then one thing that we don't typically talk about, or at least celebrate as much, is how design assist can impact a successful installation in the field. So in-house expertise. Driscoll works on some pretty significant sized projects, healthcare projects. There's a lot of building science, regardless of whether it's facades, life safety, code analysis, vertical transportation. So 30 years ago, Ken Anello, our president, created the engineering department and was really focusing on commissioning of buildings. Throughout the years, it's grown. I took over as director of engineering for Walsh Consti, which I'm sure most of the people in the room have long-term experience. So I had the pleasure of being mentored for 15 years on how to use Design Assist from a facade perspective from one of the legends. As I said, we have a team of Michael Orlando, who's a licensed architect who helps out with regulatory, life safety, healthcare. David Murphy, who's a life safety and commissioning specialist, as well as fire protection specialist, and Mike Walsh, who manages vertical transportation. Once again, these experts, we're not only using Design Assist for facades, which is where most people are used to seeing those activities occur. We're really trying to identify all these aspects of building that require expertise that your new APM or even your seasoned PM might not understand the nuts and bolts to the level that we need to ensure that the subcontractor does to ensure success for the projects. So Design Assist, designing to a budget and budgeting to design. So these lean ideas of target value design is really what we've been doing for years. And the latest contractual method is integrated project delivery, where we use Design Assist, where we actually have a key trade partner who signed up. Their profit and overhead are defined and guaranteed, and essentially you have a transparent budget that's created during SD that you're working towards all the way through CD to deliver the project, so that there's constant transparency for the owner of what that element of the work is going to cost. Regardless of whether it's IPD or if it's a GMP project for L.F. Driscoll, we've been utilizing just Part A, Part B subcontracts for years, which is, essentially we'll go out, competitively bid these scopes, glazing, metal panels, prefabricated elements, identify what the subcontractor thinks the overarching cost is going to be based on, 100% DD drawings, identifying scope gaps that they see, identifying value engineering strategies, putting numbers to that. This hopefully is not like a 1 week exercise, right? Hopefully we're giving 3-4 weeks to really allow the subcontractor to ask questions, be introduced to the design team, and really identify a partner that the Part A is, hey, for 16 weeks, what is your engineering and design resources going to be that we're going to work towards that target value that you've created for yourself. And sometimes that target value doesn't necessarily mean that the low number receives the project, right? It could be that somebody's general understanding of the scope today is higher, but their engineering resources they bring in and the creativity they bring in their menu of what the value engineering opportunities might be could bring that to cost neutrality, savings, or just in general, sometimes owners want to pay for the people that they have the most confidence in. So certainly those engineering teams are more important or as important as the final number. And then ultimately, even if it's lump sum, Driscoll feels that it's important to use this opportunity to coordinate with the architects that if there are changes that are needed within enhanced coordination, that we are tracking these costs, that the subcontractor is not giving this stuff away for free, or that it's being applied to them or pressured upon them, that we are trying to act as a teammate to ensure that what's going in is producing what the owner actually wants. So traditional design assist activities, from a design perspective, we're looking for a trade partner, to help confirm geometry, confirm key elements of the design, what's important, what coatings are important, is performance important, is aesthetic important, is sustainability, what are the key drivers? You can't have everything, so what are we really working towards? We're always looking to, when it comes to curtain wall, verify the system design, glass sizes, and all of that's going to tie into ultimately how is that tying back to the structure. So how do we get imposed loads back to the engineer of record and also to the concrete sub and the steel sub. Ultimately, design assist is most effective when there is someone, from the electrical side as a subject matter expert that isn't only getting the savings or getting the opportunities or the quality out of the singular design assist side. We need somebody that understands, how is that savings or how does that efficiency impact, speed of concrete, or what do we need to pre-coordinate to be welded in the steel facility in lieu of doing that all in the field. If you solely purchase a design assist scope and say, hey, Glazer, you're going to manage design assist, you're going to take the notes, you're going to do the tracking of financials, they're only knowledgeable about what they're bringing to the table, their systems, right? So Driscoll is really trying to take ownership of something that we used to purchase out and actually manage that so that we can make the ties between the glazer, between the metal panels, so make the savings with the concrete pour, how many embeds there are. It's not a guess, so we're able to purchase that in real time based on these early design assist package with the facade engineers. We talked about engineering and obviously samples, prototypes, and mock-ups, using design assist to identify, what prototypes need to be done to ensure that, the geometry is truly, what is the architect's intent, and the image on the right or the left. That's something where our energy science building at UPenn, there was ETFE, single tension membrane, was a unique feature for that project that hasn't been used in the city. So Penn wanted to see, hey, do I truly want this? Is it as durable as being sold? I understand that it's going to function as a solar shade, but hey, let's build this traditionally out of perforated aluminum as well, so that we can really compare these two, so that when we go out to bid, or we have our final per E value, we are sure that this is what we want. So as I mentioned, real-time cost estimating. We take those value engineering ideas, and we put them on a piece of paper, and we say, hey, owner, your scope of work is this current scope of work is going to be this much money. We believe that there is potential savings of this, and along the 16 weeks on a weekly basis, we're going to work with the architect, the engineer, and the subcontractors to validate, was that projected savings or that design change, is it aesthetically palatable? Does it actually come with cost savings? And do you want to, approve that change before we get rolling on the project? So, for example, on this north facade of VLEST, the original architect's design, had every floor of the curtain wall staggered. The verticals didn't align. We thought there was potential of savings that if the verticals aligned, it makes it easier to transfer load from unit to unit. It gets away from shear connections for wind load anchors between unit to unit, and it really cut down the uniqueness. Although it doesn't look like it, it cuts down the uniqueness of the unit sizes, by 30%. So this is one of those elements that we're tracking, and in reality, this is a bad example. Or maybe a good example. The owner looked at this, saw that the savings wasn't necessarily as much as they were thinking, and in lieu of having the architect redevelop all their elevations, wall sections, they chose to not proceed with this one. And once again, there are other examples from that project where between 7 or 8 different ideas, we were able to save $150,000 with essentially no impact to the aesthetics, and certainly an increase in performance. So, once again, we're using real-time logs, owner risk and opportunity logs, so that the budgeting and the transparency of that money is happening on a weekly basis. So they're able to track, because they're out there monitoring what's happening in my HVAC well, what's happening in my fit out well? Where am I gaining opportunity to get cost surety on the facade to say that if I have $500,000 of savings, that element on the interior that I wasn't sure I can actually, afford, I now can allocate that money, right? It's creating opportunity for the architect in ways that, if you were waiting for a lump sum or you were waiting for, the building to be complete to actually figure out what the number is going to be, there's lost opportunity. So system design, the gentleman earlier was talking about the transitions, right? So the price of entry in Design Assist for us is, these multi-trade transitions. Who owns it? Individual subcontractors own it, right? So, as much as I'm sure my bosses don't want to hear this, we own it, right? Like if we aren't the ones coordinating between the subcontractors and helping define where goes where, when these things come together, performs the best based on our historical knowledge and analysis, and knowledge of our key trades, our sort of patron saint trades, how their systems work. If we don't bring that information to the table, then you're just reinventing the wheel every time. So, this is Atlantic Care Gallery Rehab. Guthrie Glass is working with us and, integrating EIFS and masonry transitions with where the seals go. Very often people are still drawing flashings that bypass the primary seal. That's something that, although we don't always have control, Elf Driscoll will bring up every single time. We want our perimeter seals to be to the primary barrier. We don't want long links of metal with splices going through a primary seal. It's a key indicator of water coming through during field testing, and we will battle, put this in front of the owner and hopefully get consensus with everyone that this is the right approach. But these are the type of things that, if the masonry subcontractor providing that flashing, he doesn't care, that the primary seal is now compromised by the splice, even if there's 2 lines of view on it. It just doesn't, these things don't compute, and no one has time to worry about it at that point in time. So that's price of entry. What happens when you get into some really complex things that you don't understand? Princeton University Art Museum just wrapped up a David Auger design, and we created a bid package, created a Part A, Advanced Glass and Metal worked with us on this project, and essentially the elevation we were looking at, at time of bid there was an elevation, the long linear window under the bronze panels was all designed as Conair 1600. As we got deeper into Design Assist, the engineer of record brought up a set of deflection diagrams that were unique, something we've never seen before. In the 15 years I've been doing it, I didn't even know to look in the S drawings for these deflection diagrams based on the cantilevers and the suspended structures. Basically that Conair 1600, with vertical walls, pressure plate system, that works well when you have half an inch, 3/4 of an inch, an inch of movement above the window that can be taken up by a caulk joint. This building surprised us with all the cantilevers and these interstitial flat spaces in between them. We were finding out that between self-weight, SDL, and SDL and live load, that we could be anticipating over 3 inches of movement over the window bed, right? So a Conair 1600 wall, those vertical mullions are static. There's no way that they are taking 3 inches of movement. Essentially we identified very early that we had a budget, we had a target value based on, a specification, but we need to reevaluate this and quickly get in front of Princeton what the actual cost of this structural glass system was going to be. Ron Kuba and his team worked very hard to come up with a system that would allow 3 inches of movement to happen over a glazing. So we ended up getting rid of the intermediate verticals, just using a pressure roll system on the jambs and sill, and then creating a custom double angle sort of channel with pressure plates inside of them that was able to sort of run up and down the glass 3 inches. It looks simple, the elements in gray on the right-hand side of that image, it's a blend of 5 structural fiberglass, a blend of aluminum angles to make sure that the thermal transfer of this system was adequate. This museum runs at 55% RH, which, we haven't had a lot of bad winters recently, but this winter was horrific. And, it's a testament to the work, and I'll show a little bit more of what it takes to meet all the performance criteria that's being thrown at us in these, highly coordinated, humidified spaces. With this custom nature of this element, we needed a proof of concept though, right? This was a unique system, never been done before, hybrid, pressure wall, hybrid structural glass. So we went to Princeton and we said, we need to do a performance mock-up. There's no way, even understanding that this is one opening, the pressures that can be applied to this system, really require testing. So, Princeton willingly and understood what they had created for themselves, supported the additional performance mock-up that was done at Malamo, where, we ended up having to build half of that opening, right? The deflection happened in the center, so we built half of it, and we were able to move that wall on the left-hand side of this image down 3 inches up, air, water, testing all to verify that, what had been put together by Ron's team was going to be effective. So once again, similarly, even when you got outside of the straight wall, we got into, and if you look at the upper portion of this, these are sawtooth-shaped windows. They were similar deflections, not quite 3 inches, but we were anticipating due to the cantilevers from the right side of this opening to the left side of the opening, was able to deflect up to 1.5 inches. And that's this opening. On another opening, it would deflect to the center. Another opening, it would deflect to the right. And another opening, it would deflect 2/3 of the way through because of these cantilevers, the structure was coming down on soft beams. And so these very funky deflections were occurring within the system. And essentially could not get confidence that a spline connected system was going to be able to take these various movements across the different openings in the three-dimensional geometry. So from day one, Ron's team, immediately started using prototypes based on pieces that they were fabricating, trying to get insulated metal panels instead of green screens put in so that we keep the water plane where the system originally, where the caulking system originally wanted to be, not bringing water to the backside of the curtain wall system that was originally designed. So certainly working through these tabletop mock-ups to demonstrate to Princeton, to Lynch's, to Ajay and Cooper Robertson, we see your drawings, we feel like it can be more successful utilizing this strategy. Continuing to develop and refine those details, once again, as I said, we were very concerned that a spline system would not be able to take these movements. So each one of the sawtooth, the L shapes, are actually individual units that were connected by an H extrusion in the center. You see it up in red. In that way, each one of these L's essentially limited the deflection that was occurring to that specific L. Everything was sort of rocking around that H extrusion. Once again, all of this, had to go through several steps of, is this the aesthetics you're wanting, visual mock-up to get the owner's approval. At visual mock-up time, you don't have the actual dies cut, you're just trying to verify that this can go together with off-the-shelf pieces, modified pieces, but we did end up going out in a full gamut of deflection, air, water testing, thermal testing on this one to ensure that we're meeting all performance criteria. One of the key elements I would say, that we're constantly working through is thermal simulations as well. And these humidified projects, they always require a level of due diligence that, there's an expense that comes with this, and there's a level of expertise that maybe not every single glazer has, but there are affordable options like Quasta out in Nebraska who, can do these studies for you where we're actually looking at what is the interior temperature, what's the exterior temperature, what's the interior dew point, and sort of model what is the anticipated sort of performance for this. And it's an iterative process. It's probably, Ron can tell you, between the project there was 70 different thermal analyses done, which once again is extreme, right? That's not the that's not status quo. That was something that came along with the specificity of this project that, wasn't fully understood even by the MDA, but I think it was understood enough that it could be covered to an extent in the Part B, that Ron wasn't just out there on his own, paying for completing the architect's design or validating the architect's design. And before we get to logistics and maintenance, the other key for design assist that we really harp on, especially for large jobs or complicated jobs, we have to go through a spec matrix. Before we're done with Part A, before we sign that initial contract, we really create a matrix, and we want our glazers and our metal panel subs, we want them to mark up the spec. What is reasonable? What is achievable? What is not industry standard? Warranties. We have to pay attention to the warranties before we sign up for Part A as a collaborative team. Ultimately, it's my warranty. Ultimately, it's the glazer's warranty that we're giving to the owner. We're both going to be in trouble if for some reason there's something in the spec that's not achievable. And so identifying things like anisotropy, like we cannot warrant glass against having anisotropy. We can't warrant glass for no spontaneous breakage. These things that we constantly see in specifications that are not achievable, they're not purchasable, therefore they're not good for the owner. So we have to work together to identify those things that when we put that proposal in front of the owner, we say this is our partner, like it's not frowned upon. We are bringing somebody that is telling you what is achievable for your project, so that when we get to the end, we're not arguing about things that were never purchasable. So one of the less glamorous things with design assist, but is important, is logistics and maintenance, making sure that we can actually achieve what we're saying, install what we're saying, especially in the load of oversized glass that we're working with in current times. And then maintenance, and making sure the owner understands that what has been drawn, what we're providing them, there are implications for their future usage. So Culver Gardens, another museum in Philadelphia that just opened up, we teamed up with National Glass, and very tall, triple glazed. This is also another museum that's at 50% RH. Both museums made it to this window with no condensation occurring on this glass, which once again is what we were throwing at this from a performance when we were down at 6 degrees for multiple days. It's really a testament to the due diligence that both teams did on both museums. So on this project, the Herzog and Dameron, Swiss architect, very particular on their detailing. I could, in a similar way I talked about how Ron designed, I could go in forever on how much National and Tom Toll worked through the details of this and the thermal analysis. All that occurred. I think what's important with this one is all that occurred, and we also, the philanthropists demanded that we retain Herzog and Dameron's aesthetic regardless of maintenance. So we're burying mulligans, several inches into, multiple layers of structural concrete. And really, when you see the size of that glass, like 6 foot wide, 7 foot wide, 14 foot tall, 16 foot tall, very oversized glass. How do you get that out if there is a future breakage? How do you guarantee that you can, without dismantling the entire wall, successfully move that? So, and even beyond, how do you get it out? Like, what are the logistics for you actually craning it? If you look at the rendering on the left, you notice there's no. This is a Dutch garden, that's probably loved or beloved as much as the building is. So there is no destroying this Pierre Ledoux, landscaping, right? So where are we going to do picks from? What size crane is going to be required? What is the cost going to be? If you go back to the details, how do you get this thing out, right? And it's under a canopy, so that this particular opening, you have the disc. You see the depressed area. Like, how do you get that? How do you have an offset jib? What is the cost of replacing this? And Joe Clavers, being decades in the business, talked about, hey, we can cut this glass free, we can jiggle blades, we can loosen up and be able to slide this stuff to the left, but we identified risk. And fortunately and unfortunately, we got to actually test this out during construction due to an errant stone flying into a piece of glass. But We ended up having not this particular opening, but one on another side with similar detailing. There was a chip in the glass from other construction activities. And we had identified for the owner that, hey, we have to buy 2 pieces of glass. We have to buy the piece of glass on the left, we have to buy the piece of glass in the center. Because if the one on the left has the chip, well, we're going to be manhandling 2 pieces of glass in order to replace this one. And we don't, you want this risk, and we don't want it, but we will do it for you, right? So we were able to identify that when we replace this glass, future replacement requires 2 pieces of glass being purchased. So when this unfortunate error occurred during construction, there was no questioning, there was no overarching concern of, I didn't know this, I didn't understand. These were, honestly, I think there was probably 4 or 5 meetings during Design Assist that were solely based on what is the logistics for replacing this glass, so the owner became comfortable with what he's exposing with, what they're exposing with. And finally, logistics. So going back to the University of Pennsylvania Energy Science building. So very unique geometry. Once again, this is a double wall. We have a curtain wall with the steel armature coming off with the stretched ETFE. And we had Driscoll had never built something like this. Most of the people that were bidding, this was unique to them. And so we were really, had brainstorming and ideas of how this would be constructed. And ultimately, just based on the tightness of the site, the geometry and the overhangs, we were very concerned about not setting all of this at once. So the overarching goal at time of bid was, let's develop ideas and pricing, assuming that these curtain wall and the ETFE structure were going to go up together in one shot. That we weren't going to set a curtain wall, swing a building, stretch ETFE, which is a method that's been used. That's how the U.S. Embassy in London was done. All the images we saw for that was sort of piecemeal together, and we just didn't feel like that was going to be the best success for us. So we worked again with Advanced Glass on this job to work about the logistics. A lot of this material was coming from Europe, so we had our ATFE sub-assembly. To reduce cost, you can see the crating of this stuff, the way the geometry of the steel frames came together. If there was 400, it came in, 8 crates, right? It wasn't just the way they were able to design the crating and stacking. We were able to efficiently get the materials over from Europe. There was a space in the shop for stretching the ETFE, stacking it all together, so that, we weren't being too onerous on space. And then, as you can see, rolling those over, putting them on the unit. And once we got on site, once again, we're in a tight urban area. How are we going to get this on the building? We can't get these on the floor, they're too large. 6 foot's not going to be able to, be swung out from the floor without hitting the transom steel. So we developed, a concept of what it would look like to deliver, 2 to 3 units on an open-air truck and set them immediately from the building. So that's originally what the Design Assist, conversation was. And, after 16 weeks, we continued to develop that. What we realized is we've got, on the right-hand side of this image, we had a plaza area that stepped down from the road. So we had a little bit of an elevation problem, but what that allowed us to do is by working with lines, okay, we need to get from street down to the plaza area in order to have a storage space for 16 units. And our field team, Nick Fazzini, Vince Fitzgerald, we were able to basically take that platform, align it with where Ron's trucks would be. If there was a day that we needed to have deliveries without clogging up the rest of our deliveries, we were able to put 16 units on that plaza area and pick from and have a spot to collect units. If there was days that we didn't have log jams, we were able in this photo, as you can tell, to just pick directly from the truck in place. So we created flexibility. And once again, there was very little impact to the owner. These weren't change orders, these were planned decisions that in our Part B, in our GMP, it was all understood and all accounted for and not something that 2 weeks in advance during our pre-install meeting we realized like we weren't going to be able to get enough units in time. And then finally, I'll just quickly show the video so you guys can see how that all worked out. So once again, one of the questions we had, and we had a performance mock-up on this one as well, that unfortunately, I believe the ETFE went in second on the performance mock-up just on timing. So his first pick was, you know, how is this unit going to actually settle itself out? There was a lot of concern, like, is the weight going to distribute itself out? Are we going to have this thing, you know, cantilevering back? And luckily, just the weight distribution serendipitously, we picked that thing up and almost stayed in line. So, got lucky there. But you see, the first day, you know, I think any job that you set, you know, almost 15 units on the first day, especially with the complexity of this, is a testament once again to that pre-planning and you know, creating a plan. So to wrap up, you know, this is, once again, we do a lot of complex buildings, even if they are, regardless of size though, like these are the tools that we implement. And we implement it because of, you know, what we do together. And certainly our subcontractors, whether it's curb wall, whether it's mega panels, you know, they're really stepping up their game, they're bringing the quality, and they're able to make us successful, you know, through us collaborating and us taking responsibility of coordinating that site so that, you know, the elements that they bring, all of the sort of building science that we've coordinated into the walls and all of the fabrication they've done, that it comes together. And so, you know, really we're better together. And we over recently, Governor 1, Jefferson High, Hudson, you know, the Morris Cancer Center, the New Brunswick with Harmon, you know, Penn Pavilion, Clifton Center, Penn Close and Wyatt, 3600 with RAK, you know, Rowan Vet, National Glass, Eastern Exterior Wall System, and soon to be Penn Medicine, Princeton, and on that side. So, you know, we really have a diverse bench to pull from. You know, everyone acts professionally, everyone's providing these services, and really it's a testament to the lack of leaks, the lack of air infiltration, the lack of icicle formation, the lack of condensation. Really, you know, it comes down to this contracting method, this early coordination, and once again, everyone taking responsibility, including the CM. What is it that you're bringing to the table? There we go. If there's any questions, free, otherwise we can talk about the details over a beer or two afterwards.
All right. Thank you very much, Sean.